Gestión, Energética, S.A. E.S.P, GENSA. GENSA, in a little more than 20 years of management, has been involved in several projects of high technical and social impact in the management, operation, and maintenance of generating plants in remote areas of the country, such as Mitu, Huapi, Bahia Solano, Bahia Cupica, and Inírida, as well as the electricity transmission lines between Venezuela and Carreño. In Colombia, GENSA is one of the largest coal-fired electricity generators who operate and maintain in excellent working condition its main asset, the Paipa Thermal Power Plant, Termopaipa. Shareholders. Its main shareholder is the government through the Ministry of Finance and Public Credit with a holding of 93.19%. Empresa de Energía de Boyacá became the second shareholder following the capitalization by GENSA of the Termopaipa coal-fired power plant. Paipa Thermal Power Plant. Geographical location. The Termopaipa power plant is located 3 kilometers along the Paipa-Dunca Road in the department of Boyacá, in the eastern central part of the country. The coordinates are 5 degrees 46 minutes 5.6 seconds north, 73 degrees 8 minutes 47.4 seconds east. Termopaipa Power Plant. Termopaipa currently has a gross installed capacity of 184.8 megawatts, divided into 3 units. The power plant is part of the interconnected system, national grid, and provides strength and reliability in the attention of the national electricity demand. Unit 1 is French technology, made by the firm Alstom. Its current capacity is 33 megawatts, and its boiler is a Stein and Roubaix. The unit became operational in 1963. This unit currently is undergoing a retrofit, and its turbine rotor is due to complete commissioning by the end of November 2016. The project, with a cost of around $20 million, will guarantee an extra capacity of nearly 6 megawatts per hour. Unit 2 was built by the Mitsubishi Company, initially with a gross capacity of 66 megawatts. The steam generator boiler was manufactured by Distro. The unit became operational in 1975. This unit was repowered by the manufacturer in 1993, increasing the gross capacity from 66 to 74 megawatts. Unit 3, also a Mitsubishi, has similar characteristics to Unit 2 and became operational in 1981 with a gross capacity of 74 megawatts. This unit is scheduled for retrofit in 2017. Total investments of around $6.5 million will grant GENSA an additional capacity of 4.36 megawatts per hour. Additionally, GENSA will buy a transformer of 90 MVA to replace the actually transformer and leave it this one as backup of Unit 2 and 3, according to a past recommendation of Loss Control Report. Summary of the units. Common systems of Units 1, 2, and 3. There are common systems in the plant for operation of the units, such as the coal storage yard with a capacity of 150,000 tons, the cooling lake, ash storage yards, coal feed systems for the 115 kV substation, buildings for maintenance and operations such as maintenance workshops for boilers, turbines, and electrical maintenance, spare parts and materials warehouse. Fuel. The power plant uses pulverized bituminous coal, which is stored in a yard with a capacity of 150,000 tons, equivalent to generating at full load for approximately 3 months. The coal used in Termopaipa comes from about 1,000 mining production units, UPM, Bocominas, from 23 municipalities producing the mineral, located in the department of Boyacá. At startup, the plant uses liquid fuel, mainly diesel and fuel oil. The following graphs show the consumption of coal in the plant per year. Improvement projects for the power plant. The mechanical, electrical, and C&I equipment have been substantially replaced, refurbished, and modernized. Actually, all are operating correctly. In 2015, GENSA had an approved investment budget of around $8 million, which were invested mainly in the following projects: retrofit turbo and extending the shelf life of Unit 1, power upgrade engine pulverizer Unit 1, speed governor and auxiliary control turbine replacement Unit 2, retrofit pulverizers Unit 2, retrofit ash transport system, preventive inspection boiler Unit 3, reconditioning 8,000 hours boiler Unit 3, retrofit pulverizers Unit 2 and 3, retrofit evacuation system of the main bench, modernization of the detection and extinguishing fire system, reinforcement structural works in thermal power plant, coal lab adjustment, enclosure and mitigation of particles from coal yard. During years 2016, $17 million, and 2017, $6.7 million, have been executed and will be executed in this investment project. 2016, retrofit turbo and extending the shelf life of Unit 1, transformer of 50 MVA and bus bar connection for generator, economizer for boiler Unit 1, curves and supports main steam pipe from the boiler to the turbine Unit 1, energy efficiency project optimization of combustion on Units 2 and 3, turbo generator structural reinforcement, modification of the bifurcated duct inlet and outlet U1 induced draft, system load control and speed control turbo generator and auxiliary equipment for Unit 2, boiler inspection predictive and overhaul 8,000 hours boiler Unit 2. Investment projects approved for 2017. Retrofit of the electrostatic precipitator Unit 1, Thermopypa. Change primary and secondary superheater of boiler Unit 1. Change switchers 115 kV, Bay Unit 1. Buy of control water feed valves Unit 2. Change of start transformer switch 52 S2, Unit 2. Energetic efficiency project combustion optimization boiler. Upgrading of the transporting ash and coal band system. Implementation of power collector on the ash silo. Other projects. Unit 1. The project involves changing the turbine for 1 with the latest technology, more efficient and reliable to increase the installed capacity from 3 to 6 megawatts, depending on operating conditions. The generator will be changed present and auxiliary equipment will be repowered. The project cost is $20 million and is currently being executed with Alstom, with an estimated duration of 22 months and overseeing a planned startup of the repowered machine in November 2016. Unit 3, changing turbine's rotor enlargement of its useful life and increase on its generation capability, Unit 3. The project includes the acquisition of a backup transformer in case one of the main units goes down. This also avoids energy holding and fulfillment with the International Insurance Market Agreement, who constantly evaluates the duties to low risk. NIT 5. This project involves the installation of a new 150 megawatt unit with updated technology using coal as a primary fuel. The budget has been estimated at $258 million. GLP. To change the starter of units from diesel fuel to petroleum liquid gas, PLG, which is cheaper and cleaner. Also, its combustion is easier to control. Operation management. There are currently about 162 personnel working in the plant with the following specialties and experience. Engineers with an average of 20 years of experience. Maintenance technicians averaging 20 years of experience and certified as technicians. Operating personnel with an average of over 20 years experience and with studies enabling their competence. Thermopypa certified for the following: ISO 9001-2008, plus extension in operation and maintenance. OSAS 18001-2007. NTC GP 1000-2009. ISO 14001-2004. ISO 50001-2011. Currently in certification process. Maintenance management. The maintenance program implemented in Thermopypa is organized systematically to prevent the occurrence of damage and is coordinated through the Informante software package. Fire protection. There are fire protection systems such as a hydraulic network with 37 fixed outlets and 14 monitors and electric pumps, protection of over 100 extinguishers, water deluge systems for transformers and oil tanks, relay room, battery room, and diesel generator room. The power plant has an AFFF foam suppression system for the boiler fuel tanks and pumps. During this term, pursuant to recommendations by JLT, RE, and ACE Group, the project is underway to install fire detectors in the areas where the burners for the boilers are located and on the level of the turbines. This project has an investment of almost $250,000. Risk rating table for the Termopaipa power plant. In ongoing visits by risk engineers of insurance and reinsurance companies, the plant has been certified year after year, noting a sustainable increase which demonstrates a commitment to actions of prevention and/or mitigation of the impacts of operational risks. To date, this report has not been received from the inspector for the risk rating for 2014. Public risk in Termopaipa. Physical security. Physical security of the power plant is the responsibility of an ex-Army major who is head of security, a surveillance supervisor 24 hours a day, and a team of guards that provide 24-hour cover. There is a comprehensive security plan for Termopaipa which describes the physical security, protection of people, information facilities, crisis management, operations manual, and maintenance, etc. There are also described and defined situations relating to emergency situations. The scheme is focused towards 4 security rings. The 4th ring is related to the community in the neighboring town, where a comprehensive social responsibility plan is carried out continuously by GENSA. The perimeter security of the plant consists of brick walls with 2-meter-high metal railings, solid walls, chain-link fencing, and lighting. The power station has a CCTV that includes 22 motorized dome cameras, mini-domes, and professional cameras. There is an agreement with the Grupo Mecanizado Silva Plazas, a command group belonging to the 5th Division of the Army. Through the agreement, a total of 36 soldiers commanded by an officer or NCO are permanently on site. Excellent relations are maintained with the police command in Paipa, who make visits to the plant twice during the day and twice at night. Non-interconnected area. Me2 Micro Hydroelectrical Power Plant. The generation system of Me2 consists of a hydraulic power plant with 4 units of 500 kilowatts, 4 up transformers, 0.44/36 kV of 750 kVA, a diesel power plant consisting of 3 Cummins units of 750 kilowatts, 1 Cummins unit of 1,000 kilowatts, 1 Cummins unit of 1,250 kilowatts, 1 substation of 3.6 MVA, 1 Cummins unit of 1,015 kilowatts, 2.015. This plant is due to start operations in February 2017. Bahia Cupica Micro Hydroelectric Plant. The generation system of the Bahia Cupica Micro Hydroelectric Plant consists of 1 hydraulic unit of 400 kilowatts, 1.5 MVA substation with a 0.5 MVA backup transformer, 1 transmission line of 13.8 kV between the plant and the distribution center. Bahia Solano Micro Hydroelectric Plant. The generation system of the Bahia Solano Micro Hydroelectric Plant consists of 5 hydraulic units of 375 kilowatts each, 2 Cummins generators of 1,000 kilowatts and 600 kilowatts, 1 transmission line of 34.5 kV between the plant and the town, 2 substations of 1 MVA, 1 substation of 2 MVA diesel. Guapi Diesel Plant. The generation system of Guapi Diesel Plant consists of 1 800 kilowatt Cummins unit, 1 MTU unit of 900 kilowatts, 3 MTU units of 500 kilowatts each, 1 substation of 3.9 MVA. Inirida Diesel Plant. The Inirida Diesel Plant has the following generation equipment: 4 Cummins units of 2,000 kilowatts, 1 Cummins unit of 1,250 kilowatts, 1 substation of 11.6 MVA.
Aceptamos retos que a otros parecían imposibles, llevando 24 horas de energía a nuestra tierra. Conectamos a los pueblos, selvas y montañas, haciendo de tu energía